The first thing I want to talk about is topology. And the more important thing about how we create topology, which is comes with a lot of experience, it's understanding what topology is. And this is a very, very complex topic. If you ask, 10 artists who are at the top of their game to model the same model or the same character for you, there is very likely that they will end up with 10 different topologies, and they're all correct because while it is a technical matter and it has to be followed, it's also a very creative process, and every artist as they go along they find their own version of doing things. I've had numerous occasions that I had to model something for work or even for classes, and I ended up doing it in an entirely different topology, which is yet very correct and very accurate, but it's very different than the previous one. And that's okay. It's just a matter of understanding what we are trying to do. Now, let me show you some pictures of what we mean by topology. So let me get rid of that. So this is one picture, the very first one I want to show you. The topology simply means how do different polygons they connect to each other. Now, you might be wondering, well, how many different ways are there for them to connect? And that's something that we're going to talk about in a moment. The topology in general means how do pieces of the model or the different pieces of different models they connect to each other, and what implications that has for what we want to do, primarily for how we want to do things such as this one, adding blends and animating our characters, or basically preparing the stage for animation. So we want to have characters that are easy to character or easy to set up the character for them and set up the skeleton so we can animate them easily. Now let me go to Maya, and a lot of the stuff that I do today, you don't need to follow me along in Maya. You're just trying to see and understand what's going on. Let me go to Maya, and then I want to ask you guys a few questions as I do things, and then we can basically work together. Here is a cube, all right, and then I have another cube right next to it. And then for whatever reason, I have selected these two cubes, I have combined them, I have said delete this face and this face, and now I want to connect these two together. How do you think I should connect them? Which vertices should I connect to which vertices? I could target well for sure, but before doing that in a technical sense, I'm wondering, which vertex should connect to where. Do you think this vertex, for instance, should connect to here, and this one connect to there, and this one connect to over there? Absolutely. Usually you don't do something like that, and like you said, you use your senses to try to connect those that are closest to each other. And in this example of mine, they fit perfectly, so they connect very well together, simply because I have 4 vertices on one side and I have 4 vertices on the other side. So that's the very first example, doing something that you know exactly how many sides are on each of the polygons. Now let's go to a slightly more complex model. Let's go to a model such as this one. I have this thing on the floor, and then I have this object up here, all right? And let's say I want to somehow connect the two of these together. So I'm wondering what I could do to basically connect the cylinder to connect to the floor, to the ground. So what do you think I should do for a situation like this one? Anyone? I could, you could snap the faces, but you usually try to work with the vertices. So, but snapping vertices is similar to faces. So when you snap a few vertices, it's as if you had snapped faces. But which face should I snap to where? Let's say this vertex, where should I snap it? I would have to add more edges. So how many more edges should I add? What do you mean, each vertex that you want on the cylinder? Let's say this is one vertex, right? So where would I add new faces? Here? I know. So somewhere like here, you mean? Like between these two? Okay, fair enough. Yeah, that's one way of doing it, and that's definitely a way that we will do it soon enough. But before we get to that, I want to actually get myself a certain understanding, and that understanding is this. In the example of the two cubes that we did earlier, like 5 minutes ago, in this example, I had four faces on the right and four faces on the left, and basically because of that I had four vertices on the left and four vertices on the right, so they could perfectly match. So before trying to connect any two objects, I actually have to ask myself, how many vertices am I trying to connect to how many vertices? So basically, for the cylinder right now, how many vertices do I have around it? How many vertices I'm trying to connect? 1, 2, 3, 4. I'm not going to count. I know the number is 20 because that's the default subdivisions around the axis. Now 20 is a lot, at least at this stage. So I'm going to actually drop this to a number such as, let's say, 8, right? So I have 8 vertices that I have to connect to somewhere. So how would I find 8 vertices on a surface? Basically, how would I find a hole with 8 sides? Let's look at this situation. If I go to any polygon and if I delete one face, how many vertices will I be left with? 1, 2, 3, and 4. I will have 4 vertices around it that I can connect. What if I go ahead and I delete 1, 2, 3 more, so basically total of 4, how many vertices I will have now? 1, 2, 3, 4, 5, 6, 7, and 8. That makes sense to everyone so far, that by deleting certain number of faces, I actually ended up with certain number of vertices. How many faces do I need to delete if I need to find myself 12 vertices? If I have 12 sides, how many polygons do I have to delete? Let me show you. If I delete all of these, I will have 3 faces on the top, 3 on the left, 3 on the bottom, 3 on the right. So 4 by 3, 12. So that's exactly the number that I have. 1, 2, 3, 1, 2, 6, 1, 2, 9, and 1, 2, and this is the 12th one. Now let's see, how does this actually come into play? Why is this important for us? So let me go back a few steps. I'm going to undo a few stages. So here. Now we have this cylinder that we know our cylinder basically has 8 sides. I'm going to push it further up and I'm going to do something like this one. Bear with me and just pay attention to what's going on. Again, don't need to try to catch up with me. Just try to understand what is going on. Here in the center where I want to connect the two of these, I'm going to do something like this. I'm going to say let's delete these. Then I will have as many vertices as my cylinder has. So if I look at my cylinder in here, I will see that my cylinder has basically 1, 2, 3, 4, 5, 6, 7, and 8 edges that I have to connect. And there are 8 edges in here. So there is 1, 2, 3, 4, 5, 6, 7, and 8. So that's basically the primary rule of making good topology, making sure that as many faces as you have to connect from one side, you allocate as many on the other side as well. But then there is another thing in here. The shape of this model here is a cylinder, which is basically like a round object. It was meant to be very, very round, but then when we make a cylinder with, for instance, 8 sides, it's not very round, but it is still considered to be like a circle. So the object here, the floor or the ground that I have, is actually a very, a straight cut object. Is basically, it doesn't have any roundiness to it. So what I'm going to do in here is this. I'm actually going to select these vertices. I'm going to scale them up a little bit. Then I'm going to select the ones in the middle of these. I'm going to scale those up. And I'm going to try to get the hole that I have in the same shape. So basically, the hole that I have on the ground and the hole that I have on the object that I'm trying to connect, they get to be similar. I go even one step further. I'm going to go ahead and say, let's select these vertices, the next range of vertices on my ground, and scale them up, something like that. Then select these guys. and then scale them up a little bit further as well. So what am I doing in here? Let's look at these faces that I have around it. I basically try to make a way that we transition from this round object to the non-round object in a very smooth way. So from one of them to the other one, we gradually change our shape. So here is very smooth round. Then the next stage is these faces, they are kind of round. And then the next stage is still a little bit round because the edges of them, these edges are still, they have a little bit of roundiness. And then the next stage is perfectly straight. So when I was trying to connect two objects together, I tried to make a smooth transition from one to the other one. Why is this important? This is important because this is exactly what happens when you are modeling, for instance, a character. You have this area, which is the eye socket of your character, and they're perfectly round. They're similar to a circle that has got a bit of a shape, but then they have to connect to the area of the face of your character, which is kind of a cylinder. Or you have a situation where you're modeling the lips or the mouth area of your character, and then again it has to connect against the face of your character, which again is like a cylindrical object. So at almost all times when you're dealing with modeling and you're trying to make yourself a good topology, you are left between two situations. One, an object that has a topology that is circular or spherical or anything like that, and then the other object which is probably a flat surface such as this one. What I mean by flat surface, don't be confused by saying that it has to be perfectly flat like on the floor. This is very similar to what you would have for a face of a character. And I tell you why. Because if I go in here, and you don't need to worry about how am I doing this, just worry about what I mean by it. If I go in here and I bend this object to a situation like this one, this becomes like a surface of a face of a character that is, bent, and then in that bend, I'm trying to connect something. So it doesn't really matter that this object is actually flat, it just matters that it could be similar to this situation. So if you learn this part, which is basically taking an object with certain number of edges and connect it to another one, you pretty much have nailed your topology for almost any situation. Now let's go ahead and connect these two together. So to connect them, I'm going to say, let's do this. Let's select all of these edges that we had at the bottom of our cylinder. I'm going to actually extrude them. So once I extruded them, I'm going to get basically one extra set of edges, right? This new extra set of edges, I'm going to scale it up. So it's kind of beginning to perfectly match what we have over there, right? I'm going to maybe extrude them one more time. And this next time, I'm going to bring it in there. I'm going to scale them up to somewhere like that. And now what I'm going to do is this. I'm going to say, let's select this model. Let me go to object mode. This model and this model, both of them, I'm going to say combine them. That's my combine tool. Then I'm going to select these two vertices. I'm going to say, let's merge the two of these together. These two guys merge it. And the same formula that we have been doing last week, that we either merge, or one of you guys suggested to do a target weld that's going to basically merge all of my vertices together. So it didn't do some of them for some reason. I'm going to do those manually. So I'm going to merge those. So let's see what happened. What happened is this. I don't need this face at the top. What happened is this. I had this shape, which was a perfectly cylindrical object. Then one step at a time, gradually, I went and I became a shape of a ground, of a floor, which is exactly the definition of what we are trying to do. In every situation, you have a very similar thing, that you have a surface, that surface is horizontal and vertical, basically something like these ones and these ones, which is the definition of planes. And then you have a round object like this one, which is a cylinder, and you're trying to connect the two of these together. And through that connection, you obviously have to allocate enough space for all of your pieces of your model. Let me show you another example of a very similar situation. Actually, before that, does anyone have any questions about the process or about the understanding of what I'm trying to do? Anyone? Hey, Of course. Yeah. Depends. So if you extrude anything, let's say I go in here and I select all of these edges and I say extrude, and then I want to do this. Well, maybe I want it to be like this, so I say yes, keep faces together, but maybe I want them to be individual, so I say no, I want to create something like this. It really depends on what you're trying to model. There are many situations where you must keep them together, and many situations that you obviously shouldn't. The default is on, isn't it for you? Okay, so I think, yeah, you go here to your edit mesh, you find your extrude. Let me find it because I always use the hotkeys here. There's a little option box next to it. If you go to the option box, actually there isn't any setting for that. I don't know how yours isn't keeping them together. Let me, give me a second. Because I've actually never have seen something like that, but I'm sure there is a setting for it that is somewhere. So we might have to find it in our preferences. In our preferences in modeling here. So do you see this in the middle of my screen? So that is in your Windows setting preferences, modeling. In the modeling, in the polygons, there is something called keep faces together that apparently for you, for some reason, is off. So you turn it on. Yes, from the once you go to Windows setting preferences, once this preferences window pops up, on the left pane menu, you go to modeling. All right, so now I want to do a little exercise with you guys. I don't want you to spend more than say 10 minutes on it, but this 10 minutes should basically very well, justify what you're trying to do. Look at a situation like this. I have this cylinder, all right. Okay, the number of polygons and the number of axes, all of those I leave it to you, whatever you want to decide. But here is what I want you to do basically. I want you to have two cylinders, all right? And these two cylinders are like this. It's like a pipe, right? It's like a connector between two sets of pipes. One pipe is coming from the top, one pipe is going to the side, and I want you to connect these two together in a way that the topology is maintained properly, the continuity of all the edges are maintained, and if for instance we had water running through this one, it would go through the other two as well. So basically the goal is to connect these two together. Can you guys get us started in this, get it done in say 5 to 10 minutes? The goal is basically to maintain the topology between the two of those. While you are working, I'm gonna do mine as well, but I'm not gonna talk over it. I'm just gonna play around. So if you wanna watch me doing it, feel free doing that. If you wanna do it on your own, again, feel free to do that as well. So that's pretty much it for what I wanted to do. I don't know how many of you were watching what I was doing, but for the most part, it's a very iterative process. You keep making stuff, you delete it, you keep making, you delete it until you're happy with whatever it is that you want to be doing. And you shouldn't be worried about, deleting stuff or recreating stuff. Any questions up until now about the overall understanding of topology or anything like that? At least up until this point of it? Okay, I want to explain another thing to everyone then. So the other thing is this. Let's say I have this sphere. When I select an edge and I double click on it and it selects the entire edge around it, this is what we call an edge loop. It basically loops itself to come back to what it used to be. So from here to here to here to here, all the way until it reaches back to this side. This should be very easy to understand. This is an edge loop. And then you have edge loops such as this one that when you select, it doesn't go all the way to the other side. It just connects from one end to the other end. So we have edge loops that is basically one edge and the other edges that are connected to it continuously going until they bounce back to themselves or until they reach the end of the model. That's an edge loop. And then if I select an edge and I hold the shift button and double click, it's basically going to select this thing, which we call an edge ring. An edge ring is the selection of the edges that are parallel to each other until again they bump back to themselves. So it goes from this one to this one to that one, all the way until it reaches back to itself, or until they reach the boundaries of the model. Let me tell you what I mean by the boundaries of the model. Let's say this was my model. All right. So my model at the top didn't have that. And at the bottom, okay, I completely messed it up. So let's say I don't want to have these guys. All right. I think the units on my Maya is really messed up, but it doesn't matter. So here I have this model, and then actually I could potentially get rid of a little bit more of it. So I have this model, and then if I select an edge loop, it loops back to itself. If I select one of these guys, it keeps looping, but until it reaches the end of the model, at one of the ends of the model. Same thing happens with the edge rings, that when you select an edge, it just rings back around itself, or when you select it, it rings until it reaches the end of the model in one of the two sides of the model. Now, why is this important? Because more often than not, when you have a good topology, you have a situation like this, that the edges of your model, they basically, like the ones around the eyes of this character, they basically perfectly loop back to themselves, or the ones around the mouth of this character. Let me show you the other example, for instance. Same thing in here. Around the eyes, they perfectly loop back to themselves, and then around the mouth, they basically loop back to themselves, and then they connect to the other areas. Where else have we seen this thing before? We saw it at the very first example that we tried to do. So here, the very first example we had was a situation like this, that I had this model, and then I had this sphere, and then on my sphere, the situation was that these edges, they would perfectly ring back, so they were all parallel to each other, and then we were trying to connect them, and that basically builds up a good topology for your model, making sure that your model has edges that they either as they go along they continue and they bump to themselves, or they go and reach the boundaries, the end of your model. Now, this is again one of those things that you try to make when you're modeling your characters. It doesn't mean we always succeed. Sometimes it doesn't work. Sometimes it does. For instance, in this little model that I made, here, if I select any of these edges, I can perfectly, I can perfectly loop back. I can actually show it to you with the faces. So it basically loops and comes back to itself. As I connected them together, I also managed to achieve the same thing. So the faces, they basically begin from one side and they end on the other side. If I had just randomly connected these together, obviously that wouldn't have worked. In here, I was luckier. I chose something that is, I know it would work easier because both of them, they were cylinders, and the cylinders, they had the same number of polygons and everything, so it was a lot easier. But if I have to connect two complex objects, we don't always get as lucky as this one. So far for making a topology, we learned these things. We try to keep the number of polygons as limited as we can. So if I have to make a model, and for my model, if I can live with lower number of polygons, such as say 16 by 12, I go with that. I don't go to random numbers such as this one, because it's going to be very difficult to edit. So that's the very first thing that we keep in mind. The other thing that we keep in mind is a very magical number. What is that magical number? Who can tell me what's the magical number we use when we do topology stuff? Anyone from everything that we saw so far? 4, because one face, one quad face. A quad face is a face that has 4 sides. If it wasn't a quad face, then it would become a situation like this one, which we call the triangle. So a triangular face and quad faces. Our goal is to stick to quads as much as possible. Like in a really amazing model, everything is a quad, right? So because when you have a quad and you want to connect something to it, you will end up with 4 sides. It stands to reason that whatever else you want to do, you do with numbers that are divisible by 4. So if you want to have a cylinder that you have to connect it to somewhere, it makes sense that for my cylinder, let me show you the cylinder. It makes sense that for my cylinder, I end up with numbers such as 12. Not there, here, 12. Why 12? Because I know if I have 12, it can be divided by 4, and then I can easily create it. But imagine if I had made this with a number such as 13. I know 13 is an odd and a prime number, but even if it was just an odd number such as 15, still it would be very difficult to connect it to anywhere. So the other part of topology is just, even though we don't want to do a lot of maths in here, but it's a matter of keeping these numbers in mind. The better numbers in general, when you are doing anything to do with topology and whatnot, are numbers such as this one. You stick to numbers such as 8, 12, 16, maybe 24, and if you have a really high resolution situation, you stick to 32. And I will show you right now in the next few minutes how these things become so important. Why do we need to stick to such better numbers for topology? So better poly count for topology. Obviously, you could begin with 4, but it's very unlikely that your model would have only 4 sides to it, unless you're modeling for like a video game, which, like a mobile video game where the performance is very important. So let's see how we actually put that into practice in terms of the numbers. Before doing that, I want to show you a few really quick tools and ways of doing things. One of these really quick tools that's very important to me is here in your your deformers. In here is called a lattice tool, and I want to explain to you what this one does. So look up here. I'm going to make myself a new scene. In my new scene, I'm going to make a cylinder. All right, I have this cylinder, and my cylinder has any number of polygons. It doesn't matter, really dense or not really dense, it doesn't really matter. What I want to be doing is I want to apply a deformer lattice to it, and this is one of those tools that we're going to add to our modeling shelf, because I use it all the time, and I'm sure once you see how it works, you will use it quite often as well. So in the lattice, here's what it does basically. A lattice puts a building box or a bounding box around your object that controls your object. So what does that mean? It means that if I right click and go to lattice points and I select my lattice points, I can actually move my model with that one. Now you might be wondering, so this isn't all that useful. So that's true. Let me show you how we can actually change the settings of a lattice. I can actually go in here to the divisions of a lattice and say I have more divisions, something like this one. Let's say 5 by 2 by 2. Then I could go to my side view, for instance, and say, give me these lattice points, rotate them maybe like this, and then rotate these guys like that, bring them in here, and then maybe do that thing with it. So I'm just basically getting a shape for my cylinder. What's the advantage of doing this using a lattice as opposed to actually selecting the polygon and changing it? The advantage is this: when you're working with the lattice, you still can change the number of polygons on your actual model. So I can select my cylinder in here and I can say, well, these really crazy numbers are not what I wanted, so I'm going to drop all of those. I'm going to say on the height I want less polygons, maybe these many polygons, and on the axis I need only a handful of polygons, maybe something like this one. So the advantage is that the lattice basically allows us to add a deformer to our object that basically adds it by adding a new input. You can see it here on the right side of your channel box that you have the cylinder, and then on top of that you have the FFD, freeform deformation, which basically allows you to modify your model the way you like it, while you can still play around with the number of polygons. So in this case, maybe after a while I realized that I like it to be like this much, a little bit more or less, or anything that it is there. But in general, lattice really helps us doing things really much faster. I think I already have a lattice in here. Let me delete it. And then what I want to do is here is I actually want to add a lattice to my shelf. So I'm going to go here to the deform. I'm going to go to the lattice. I'm going to say the settings that I want for it are, the default settings are 252. Let's say create. And then of course I don't need this lattice. What I do need is hold the control and shift buttons and say here, add the lattice to my shelf. So here, so it gets added in there. Let's see what we can do with it again. So now if I tap on that lattice, it automatically builds this for me. I can select my lattice points. I can move them around to get whatever shape that I want for my object. You will see it in a second how I use this to my advantage when I'm doing modeling for my characters, which we'll hopefully get to it in the next few minutes. One final thing about lattices. Lattices, they have a built-in feature which basically, in a very programmatic term, basically it defines the way that the lattice interpolates between its very own points. What does that mean? Look at this situation. I have the lattice points that they're basically going at the top from right, and then in the middle they're going to the left, and then they're coming back to the right in here. Now if I go to Control A or go to Attributes Editor, here if I select my lattice, it has a little thing called local, and if you get rid of that, it basically makes a very smooth transition between the points of the lattice. That's not always the case. There are many situations where you don't want it to be like this, but then there are also situations that you want your lattice to make a smooth transition between how it is doing the different deformations. So just keep that in mind, that your lattice has a built-in parameter called local, which you can translate it as the smoothness of transition between the lattice points. Once you do this, and once you go to your model and you tell yourself, well, the numbers that I need are, for instance, I don't know, say 12, 10, or actually 10, 12 is actually a good number, maybe a little bit less, 10 and 8, for instance. Once you're happy with this number and you know these are the ones you're going to go with, then we don't need this anymore, this construction history anymore. So we can actually go to Edit, Delete by Type, History, and that pretty much eliminates this construction history, makes sure that our models, they don't really have that history anymore. That makes sense to everyone up until here? Any questions up until now? To do what, sorry? To select an edging was shift and double click. Yes, so you select one and then you click the other one. Yes, it selects that. Or if you want to select an edge loop, you just double click on an edge. You can also do the same thing with faces. So you can select this face and then double click in there, it selects the edge, basically the face ring loop for it, face loop for it. So when you do this, let me make sure it shouldn't be any different than a Mac or a Windows. So when you do this, it doesn't select the ring for you. So it does basically this, which is, let me see. This is a fresh installation of Maya, and I didn't copy my own preferences because I didn't want to have anything in there. So this should be identical to what you guys have on your machines. But let me just quickly double check to see if there is any reason why that shouldn't happen. Your wishes, no, none of these things. And in the mesh selection, go shrink. Could it be that there's something going on with your shift button, or I don't know? That's because if it worked once or twice, then it's probably working, but we just don't know why sometimes it's not working. Yeah, okay, let me see. So most times, so basically that tool is here, right? So that's in your select convert selection, right? When you go to select convert selection, you select one, and that one, when you hit the edge ring, it becomes edge ring. So the shift and that's meant to do that. But honestly, I'm not sure if it sometimes doesn't work for you. I'm not sure why that is happening. Does it work with the faces, or just doesn't work at all? Okay, so on the faces, when you do this, it just does that. Okay, just so I'm clear, because I just realized this might be because you can't see my mouse pointer, right? How do you make the selection? Okay, so you select one edge, like the one I'm selecting in here, then you hold the shift button, you go to an edge that is parallel to that one, right? And double click. Yeah, sorry guys, this whole thing with Discord, and I don't know why they're forcing us to do Discord, because you can't see my mouse pointer. I actually have a sticky in here that tells me be mindful because they can't see your mouse pointer. This makes it very difficult because a lot of times it's just I just, you know, by nature I press a button, then I realize that, oh, you can't see my mouse, so I actually have to explain what I did. So again, really sorry for that, guys. If you're trying to select an edge loop, you just double click on one. If you're trying to select an edge ring, you select an edge, then you hold the shift button, and then you go to an edge that is parallel to that one, and you double click, and that should select that. The very same system works between two faces that are parallel to each other, such as these two faces. I'm going to select one of them, I'm going to hold the shift, double click on the other one, and that selects the loop of the edges of the faces there. Okay, so now let's move on to seeing something that this I want to just, you know, get us started with it, and I want you to begin thinking about it this week, and then hopefully next week we will end up you know, fixing it properly. The way that the one I want to actually go through it is this. I want to show you a 3D model, the way we go step by step by step. and then we see how it works. Let's go ahead into my models. This is the very first basic model, basically. So let's look at this model, and I don't really want to see any of the 3D or the characters or anything. Basically, I want to hide all of these things for now. So this is the model that I want to model. This is a cartoony drawing of Mr. Obama's face. I found it online. It's a very interesting drawing, so I decided to model this one. What this is called when you are drawing characters or modeling characters, this is called a model sheet. So if, for instance, you go online and you search for a 3D model sheet, you will find tons of those that are drawn by other people, and then 3D model sheet. And if you're good at drawing, you can basically do your own version. And even if you're not good, such as myself, you can get inspiration from the ones that are online, try to modify it to your own liking, and then make the model that you need. In a nutshell, basically what it does is this. It basically draws one side view of the character and one front view of the character. These two are what's absolutely needed. But then a back view or a top view or anything like that, if you have the luxury of it, by all means. If you don't, it doesn't really matter. But basically having a front view and a side view tells you as a modeler how to model it in 3D. Look at an example such as this one. So this is basically a side view and a front view of some sort of a rabbit, apparently. And then they have a back view as well, which again doesn't really matter as much, because most of whatever is in the back view you can infer it from the front view. But that's basically what you need for modeling characters for the most part. Model sheets that they show you at least two sides, at least the front and a side of your character. Let me find another one that is a good one. Let's say front side. So anything like that you find online, that people, they have shared their stuff. And again, if you're designing a character of your own, you obviously designed at least the two angles of it. But that basically tells you how should your model look like in 3D. So that's what I have found in here. Again, I'm not a 2D artist, so I can't really draw much. So I actually found this work by a Jasper Uvegan, if I'm not wrong, his name was. It's a very interesting drawing, so I decided to model this character. Before I go through the steps, I actually want to show you the final product, so you can see how we go from this 2D design to the final 3D model. So here's the final work that I did. Obama 10. So this is the final model, and if I make it smooth, you can see that it's a 3D model that looks similar to what they had on the drawing. Something to keep in mind, that this I have seen it over and over and over. You can absolutely never make your 3D model be exactly the same as your 2D. At some point you have to detach yourself from the 2D and just move on with the 3D version of it, because there are things that you can actually do in 2D and they look a certain way. If you try to achieve exactly like those in 3D, it doesn't look good. At some point you have to tell yourself, well, I have drawn inspiration by my 2D design, and now I'm actually doing some stuff in 3D, because in 3D it looks better in a way or another. So this model doesn't really have to be 100% like your 2D. You have to begin with your 2D, and then at some point you tell yourself, now I'm going to do things in 3D. Now let's look at how I actually went through the steps of modeling this thing. I kept 10 copies as I was working, so it kind of explains what I have been doing. So the very first one is the one that I had opened just a second ago. So this one is just the basic of the shapes. So here I have the side view of the face, and I have this sphere that represents the basic shape of the head, and I have this cylinder that represents the basic shape of the neck. None of these two things, they have any details on them. They don't look anything interesting, to be honest. They look like just two pieces of model that are like that. The one thing I have done in here, that is using a lattice to reorder my stuff, and the reason for that is that I wasn't sure how many polygon I want to use for my head. Do I want to use like a situation where there are 16 faces? Do I want to use a much higher resolution or a lower tessellation? So for that I've used the lattice. There's also another reason for doing that, and let me explain this to you first and then I jump back into there. As you can imagine, if I have a sphere for the head of my character and I want to have a cylinder for the neck of this character, at some point they have to connect to each other. There's no question about that. So let's say this is the sphere and is over there, right? And it's going to be the the main bulk of the head of my character. And here is a cylinder that's going to be the neck of my character, right? Can anyone tell me what should I keep in mind for connecting these two together? How should I think about it? Perfect. The amount of polygons that the two of these they have to match. The default numbers are 20, so they do seem like they are perfectly matching. Like these two faces, this and this, they perfectly match, and then the next one, the next one, the next one, because the default number is 20. So if I'm designing something of my own, I have to keep these numbers in mind. For instance, if one of them was 24 and then the other one was a very bad number such as 15, then there was really no way for me to connect them. Obviously there are ways, even if I mess things up as bad as this, but why should we do that? We try to make sure that right off the bat we stick to good numbers and we plan things properly so we know what we are doing. That's one step of the process. The other step of the process is this. Let's say I want to make this model to become the overall shape of a head of a character. So I'm going to select this model and I'm going to say I have this construction history on the side. I can change the number of polygons. That's really going to help me, do whatever I want to be doing. And while I'm here and I have access to this, I'm going to add myself a lattice. And this lattice, even though my default is a 2 pi by 2, I can actually increase it to be a little bit more detailed. So I have a lot more details in it. And then here is a very, very important part of the whole process. If, for instance, the neck of my character is here based on my drawings, the neck is here. For whatever reason, the neck of the character is actually placed in a situation like that. I'm going to tell myself where around the axis of the neck, I want to have 16 polygons. So if that is 16, then around the axis of my sphere, I also have to have 16 polygons because I want to make sure that they 16, not 61, 16, because I want to make sure that they perfectly match one another. Let me drop the height more. So I want to make sure that they match each other perfectly. Then the more important thing is this: where the head is going to connect to the neck, I got to make sure that that place is like the bottom, or what you call the pole of the sphere, like the pole of the earth that is on the top and on the bottom. I have to make sure that they perfectly match each other. What do I mean by that? I have to do something like this. I have to select my lattice and say, well, this one, I want to move it in here, rotate it a little bit like that, put it almost in the middle of my cylinder. It doesn't have to be 100%, it's not an engineering task, but I want to make sure that they kind of match each other perfectly. And then I want to just rearrange everything accordingly, so they basically cause some sort of an approximation between the different parts of this model. Of course, I'm going to go ahead and increase the number of polygons on it. Maybe I go to somewhere like 12, so I get a slightly better shape in here. Then I'm going to go to my actual lattice. In the lattice, I'm going to say it's in the local mode, so it causes the approximation to go very smoothly between the two of those. So that is there. This I'm going to push it here. This I'm going to push it there. So whatever shape I'm trying to get, I make sure that one pole of my character, of the head of the character, ends where the cylinder is, or where the neck is. That's one part of it. The other part of it is I make sure that the other pole of it, which is this one on the top, it ends up somewhere at the top of the head where I don't have to worry about any features. where there are no eyes or no ears or no nothing. So overall, a shape like this would pretty much get the work done for me. That a shape that has the pole of it connecting to the neck and another pole of it at the very top of the head. Let's see how I have done this in the model I was showing you. In the model I was showing you, I have a situation like this one. So here I have this model that the one pole of it is almost here where the neck is connecting to the head. The number of the polygons on both of these I have to set to make sure they have the same one, and then one pole of it is here at the very top of my character. So this way, let me get rid of the X-ray. This way I make sure that at the top here there are no features. I just want to perhaps make some hair, so it's very easy. And then at the bottom in here it's perfectly aligned to match with each other. So what do I mean by perfectly aligned to be matched? So if I move this object around, if I move it lower, I can actually go to this and say select, for instance, this ring. And then you see, if I go in here and I delete this, it makes the perfect connection between the neck and the head. So I can easily go in here and say, well, let's connect the two of these together, because the number of polygons, if they match, and the shape of it, if they match, I can easily connect them together. And that's what I have done in the next phase of it. The next phase of it, I've said, let's go ahead in here, and it shows that I've basically connected the two of these together. I was sure of the number of polygons on each side of it. I was sure that, you know, they would perfectly match each other. And now when you look at it, if you were a complete novice and you hadn't been in this class, you couldn't tell me where would the cylinder begin and where does the head begin or where the sphere begins, because the whole thing has one real continuous, you know, set of polygons. Here, if I look at my polygons here, the rings in here, they're doing perfect work. They go from one to another, to another, to another. Everything is working really, really well. This makes sense up until now. So up until this point, my character has the basic shape of the head of it. So I've looked at it from the side view in here. I have used my lattice to shape it like this. I've then looked at it from my front view, and from my front view I've gotten the overall shape of it. The shape isn't perfect, there's a lot of work to do. Also, like I said, the shape doesn't stay faithful to the 2D. I've never seen that happening, because at some point you look at the 3D and you're like, oh, that sucks, I have to change it, because in 2D it looked good, but when I came to 3D I have to actually make some changes to it. So for instance, for this one, the neck, the shape that it had, I didn't quite like it. When I went to 3D, I decided to make the neck different. So don't worry about doing things as such. The next thing that I wanted to do in here is basically the shape of the eyes. So I went in here and I made these two pieces. Are these familiar to anyone? Can anyone recognize what kind of model this is? Anyone? It's just a plane. Anyone else? What kind of default or primary object do you think would make this? Let me show you what I mean by that. Let's go ahead and say I only want to keep this one. All right, so this is the only object I want to look at. Let's say one of you suggested this was a plane. If I do this, does this look like a plane? The way the structure of these are made, the way that the edges are continuing from one to another. As a point of reference, I'm actually going to put a plane right next to this so we can actually see them side by side. So here is a plane and that is the model. So in a plane, the edges are always continuous. They go from one to another. Again, same thing. They're always vertical or horizontal, right? In my model, they're actually quite round. Do you see how they are round? So it feels like this model wasn't built from a a plane, all right? It was built from something like a cylinder. So if I go back, I can actually say that it was probably a model such as, if I actually push this further down, push that one, not like that, push that one further there, all the way. You see, one step at a time is getting closer and closer to a shape of a cylinder. Of course, a very heavily adjusted cylinder, but still it does feel like an overall structure of a cylinder. A cylinder that has these faces, and then the faces, they keep growing. Of course, this wasn't really the approach I made the eyes. I actually used the create polygon tool because I felt like modifying a cylinder would be very, very difficult. But the goal in here is, this is what we have to understand. If this is a shape of a cylinder, then I look at the edges around it, these edges, and I count the number of polygons. I don't really need to count because as I was modeling, I kept that in mind. But what I mean is that you keep that in mind so you know how many are there. But in my case, I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it says there are 12 polygons in here. What does that mean for us? Does everyone recognize that these 12 edges, the outer edges of this eye socket, basically, these outer edges, they actually have to connect to the surface of the model. Let me reopen the model because I kept deleting stuff and I didn't keep that in mind. Display, show all, I guess. So let's say this is my model and this is the shape of the eye. Do you all recognize that eventually, one way or another, I have to actually connect these two models together? So this has to somehow connect to there. That makes sense? And that is kind of the challenge that is up ahead of us. So for instance, if I go in here, and I'm only going to do a little bit of it because I don't want to put a lot of time on it in here. I think we're already over time today, but I'm going to go ahead and say, let's delete one half of this and let's delete the other half of the actual model. So, and I don't need that. I actually don't need the eyeball in the other side either. So here I actually have to connect this model with this object. And I have counted and I have learned that there are 12 polygons around it. If I have 12 polygons, remember, we have to delete how many faces? If I delete these many faces, how many edges will be left around to connect to? Can you count? 12? Perfect. So that is basically what I have to do. So I have to come in here and I have to say, well, if I, for instance, deleted these faces, then I will have all 12 of them. These faces aren't really in the perfect place, so I'm actually going to go ahead and make some edits to them before I delete it. What are those edits? And this is a very interesting thing that happened because we saw this just a few minutes ago, and that was when I was trying to go from the cylinder to the plane. I said the cylinder is circular, the plane is perpendicular basically, so I tried to approximate the shape. I tried to go ahead and let me quickly redo that so it's a bit of a refresher for everyone. So I went ahead in here and I said, if I'm about to delete these 9, here's what I'm going to do. I'm going to select these and this and this and this, and I'm going to do something like this so I get a slightly rounder shape. This shape that is rounder is very similar to the shape of a circle, and that's going to really help me in connecting the two of them, right? Because a cylinder was like that. I'm going to do exactly the same thing, or basically I'm going to stay true to the same shape or same ideology in here, that I'm going to try to make a round shape in here. So for instance, what I could do is this. I could actually go ahead to my side view. I don't want to see the faces in the back, so I'm basically going to cut these faces. It doesn't matter because later on we will, reconnect them back together. When you're modeling, a lot of times you end up doing this, separating pieces, reconnecting them, doing things as such. Then I'm going to go to my front view and say, well, I want them to be a little bit more closely similar to each other. So what if I do something like this? What if I said, let's push these vertices higher. So it's getting to be a little bit rounder than what it used to be. Bring this one a little bit closer. Bring this one a little bit lower. That one about there. Do you see, one step at a time, my model, the face of the character, is getting the shape that can accommodate for the shape of my, for the eye socket that I have built. So that is where I can actually start connecting them together. So I can basically go ahead and say, let's get rid of all of these. The faces over there, and these two now can be connected together to build the shape of my model. Of course, it doesn't really end in here. There are quite a few other steps that I have to do, and that basically becomes the next step that I have done, which I basically connected the eyes. And when I connected the eyes, I ended up with this model, which basically in the connected version of it, everything works, but the character looks really creepy because it doesn't have mouth, doesn't have nose, and I can't really see a lot of the features on it. I don't want to go through the rest of this because this is something to do for our next week, but by the end of it, we eventually add all these separate pieces, the pieces that they basically build our character. I want to quickly show you the topology of it, and then we wrap it up for today. The topology of it works like this. If you look at it, I have these polygons that they are basically perfectly circular, or like a cylinder that they connect to the rest of the head. Then I have the around the mouth and the lips. So these. So this is another area that is, perfectly circular, then connects to other areas. Even that step of it, it works perfectly fine over there. I have a very similar situation with the ears. So again, here it connects. Let me get rid of the hair because that's really not something that we worry about just now. So here, one more time. So that's basically where the head for the ears are connected. I could actually separate this out so we could see what's happening with each of those. So here I'm gonna say, so this is one object, the ear, separately created, but I knew how to connect them together. So that worked really, really well for me. This is the other object. Let me go back to the object mode. For some reason, my machine is slowing down. I think it's because OBS is recording the screen. So then I would have this model basically, which is for the eyes. So I'm going to actually extract and separate this part out. So this would become the eyes, or the eye socket rather. I would have this one for the lips. No, not like that, like that. Maybe like that one. So I'm going to actually extract and separate this part. So as you can see, each part of the model on its own is not all that difficult. You can build them, but then when you want to connect them, your topology becomes important. And when you put them all together, you obviously end up with a model that everything works on it. The topology of it is in a very good situation. Almost, I think, if I haven't made any serious mistakes, which I doubt it, almost every object here is a quad. So there isn't any other type of polygon. Everything has 4 sides, which is really perfect. And then the low resolution of it allows me to make any edits that I want. And then a smooth version of it, or the higher resolution of it, allows me to do rendering. So if I smoothen this up, we will get to see this character that is a very, very smooth model. Let me increase the divisions to, for instance, 2. It's a very, smooth model, and it's a perfect character that has every edge of it is perfectly drawn. There is a perfect topology for it, and it can be easily animated, for any purpose. Any questions up until here, guys? Anyone? Yes, that's actually a somehow relevant and somehow not as relevant matter, because your sculpting doesn't really affect your topology in any way. Let's say you have this model, and then I'm going to go to the sculpting. I'm going to begin my sculpting tools. Let me pull up my tool settings. Say I want it to be a lot less. Let's say 1, and size of it that is. Can I reset this tool so I can see it? Give me 1 sec. I have to clean up this model before I can actually this thing on it. So here I have this model, and in this model I'm going to go to my sculpting tool, and in my sculpting I actually want to again, this is very large, so 2, that's very large, 0.2. All right, so here I want to do some sculpting. You do your sculpting over your existing model. So whatever you're trying to do with your character, you basically do it. This model doesn't let me right now, but whatever you want to do with it, you do it on this topology. So the challenge becomes this: you either have a model which is very low resolution, like the one that I had in here, which sculpting on it is actually very, very difficult, or you build a character or a model that has a really high resolution, where we have a very high resolution. Then the problem becomes that as you're trying to do your modeling using the sculpting, then you have to redraw your topology over it. That's an entire field by itself. If you go to places such as ZBrush retopology, which is basically a way of converting one topology to another one, an extremely high resolution or messed up model to a low resolution one. So the understanding of how you should do your topology stays intact. You still need to know how to do it, but then, for instance, in a situation like this one, this is actually a very good example. So if I can show it, this one to you. So in this one, for instance, the image on the left is the one that they have sculpted. Doesn't matter, Maya, ZBrush, Mudbox, or any other tool. But then once they had that really high resolution model, you can't do anything such as animating or whatever on it. So what you end up doing is you end up redesigning it in a place such as Maya, which is what this artist has done. They have actually gone over their model and they have redrawn the polygons. What's the advantage of this? The advantage is that when you're drawing the polygons, you don't really need to think about the shape of it anymore, because the shape of it is already there. The way we are doing it right now, on the fly, you have to think both about the modeling issues as well as the shape of the character. You could eliminate that by saying, hey, I'm going to sculpt everything. But then to do a sculpting, you need a lot of artistic skills as well to know how the sculpt is actually going to, get the shape out of what you're trying to do. So it's a bit of a double-edged sword. Either of them has its own advantages and disadvantages. That's why even though it's like 15 years sculpting is in the industry, from ZBrush to Mudbox or whatever, not everyone is always using it. There are ZBrush artists, and then there are modeling artists that they do things using modeling tools. That makes sense? Over the next few weeks, once we get a bit of a better sense, we will go over sculpting in Maya as well. But like I said, the sculpting is gonna help, at least in the way that I do my modeling. It helps in modifying the models, not actually modeling them from scratch. Alright guys, so I think that's pretty much it in terms of what I wanted to show you. What I want you to do in the next 30 minutes is get started with your assignment. Go through what you have to submit, and also try a little bit of a practice in terms of doing topology and connecting models together. I will be here to help you, whatever you need. And yeah, that's pretty much it. Any questions? I could, yeah, that's okay. I will upload it for you guys. Yeah, don't worry about it.